Okay, guys, this lesson is on wholes. This is week 2, lesson 1, I think. Anyway, so this is about wholes. So hopefully you've already watched the video sort of on the introduction, so you know what a hole looks like. And you've gotten this particular chart that you're looking at right here today. Again, for this lesson, I'm only focusing on wholes, literally just this part right here. Okay, so you can read it, and I'm not going to read it to you. You're smart people. You can read, but let's show you how to do it. Okay, so here's this function right here. Now, wholes are dependent on a common factor. Okay, that is the most important part of wholes. So if you'll notice on this function, the top is factorable, right? So you're going to have to do this first. Wholes always come first. So when I factor this, I can tell that there is a common factor. These two are exactly the same, right? I will be able to cancel them out. Before I cancel it though, right? Before I cancel it, I want to look and ask myself, what would make that factor, or this one, it doesn't matter, what would make that equal 0? And I think that you would agree with me that if x is equal to -3, I would get a 0. So I'm going to write that down. I'm going to leave it there. And now I'm going to cancel these out. Now, when you cancel this, I want you to sort of, in essence, cancel out the original too. I don't want you to ever look back at the original. It's gone. It doesn't exist anymore. All that's left is f of x is equal to x minus 3. That's all that's left. So now, as far as the whole, I have the x part of it. It's right here. I wrote that down. Now I need the y part, right? I'm missing the second half of this whole. So to get the y part, you take the x part, you take this value, and you plug it in. So if I evaluate my function at -3, I get -6. That is the whole for that original function. This ordered pair right here is the whole. Okay, let's try 3 examples total. So let me zoom. Well, that was not what I wanted to happen. Again, if you watch my first video, you know that mistakes are going to happen. I can't seem to move this down. What the heck? Give me a sec. There we go. All right. Okay, so for this one, again, you always have to factor to find wholes. So let me factor this top, which I'm going to do by grouping. So if I pull an x squared out of the first 2 terms, I'm left with x minus 1. And if I take out a -4 out of these two, the second 2 terms, I'm left with x minus 1. And the denominator is already x minus 1. So let me continue to factor by grouping, and I get x minus 1 times x squared minus 4 over x minus 1. Now notice this is a difference of squares that is still factorable. I'm gonna move over here. So now I have x minus 1 times x plus 2 times x minus 2 all over x minus 1. Okay, so there is a common factor. Right here you can see there is a common factor. Okay, so as far as the whole, which takes an x part and a y part, I know the x part. The x part is 1, because if I plugged a 1 here or here, I would get a 0. So now let me get rid of this, right? I have now canceled out. I no longer have that term. In fact, this whole original function doesn't exist anymore. So now to get the y part, right, I'm still missing the y part of the whole. I'm going to take 1, the x equals 1, and plug it in. So 1 plus 2 times 1 minus 2. So this becomes what? 3 times -1. I believe that would be -3 for a whole for this function. Okay, and then this last guy. Ooh, this is kind of interesting. Okay, so let me, I'm going to need to factor, right? Always factor first when you're finding a whole. So I have a -1 on top. This, in parentheses, is a difference of squares. Okay, it's kind of an interesting difference of squares, but difference of squares nonetheless. So let me factor that. And the denominator. So look at this. I do see a common factor, but before I cross it off, right? Before I cross it off, I probably should factor it just a little bit more, right? This thing does factor even more. It factors to be x plus 2 and x minus 2. And down here, this is also x plus 2 and x minus 2. So this is a really great problem, and the reason I like this one so much is that there are two common factors. There's this one, which is going to give me an x value for the whole at 2, and then there's this common factor, which is going to give me a completely different whole. Okay, so two different x values, two different wholes. So let me cross these off. Right? Let me cross those off. My function now looks like this. The original one no longer exists. All I have is this. So let me get rid of the original, right? I don't even want you to glance back at it. Okay? This is what matters. So I need to plug both -2 and +2 in there to get the y part of the whole. Okay, so if I put -2 in here and I square it, that gives me 4. 4 plus 4 is 8, times this -1 gives me -8. All right, and then if I put +2 in here, right, in there, and square it, I get 4, plus another 4 is 8. Oh, look at that, the y parts are the same. All right, so this particular function has two wholes. All right, there you go.